Hey guys, and welcome to an introduction to technical drawings, where we're going to talk about what technical drawings are and what technical drawings are not. So here you see a diagram of types of drawings, and so we're not going to be talking about the artistic types, we're talking about the technical types. So 3 different types of technical drawings are sketches, diagrams, and then the drawing or technical engineering drawings, which are the different perspectives. So to start off, whenever we're talking about any of these types of drawings, you have to visualize and draw. So visualization is your ability to create and manipulate mental images. So have a mental image in your mind about what you want to draw. And then drawing is the ability to put it on paper. So why is this important? Well, images can be visualized by showing how an object's geometric elements are related. So looking at the faces, the sides or planes, you're looking at the edges, the lines, how 2 faces intersect or changes in contrast, the vertices or points, 3 or more edges intersect, and then the curves or the surface limits. And so when you look at this example of the semi-cylinder, you can see how all of those different aspects of geometric elements combine. So different types of technical drawings or drawings. We have conceptual sketches. So when you first get an idea for something that you want to build, you're going to draw it. You're going to draw it roughly using just a pencil, using no instruments and or accurate scales. This is called a conceptual sketch. You see this a lot inside engineering notebooks and inside of drawing notebooks, people thinking about ideas and putting them onto paper. So it allows you or an idea to be expressed quickly in graphic form. It's prepared freehand without drawing instruments. It is not done to scale, but it represents the rules of technical drawing as much as possible. And it's roughly made proportional size as the object is represented. And you can see here we have a conceptual drawing of a futuristic looking car. Technical drawings, they serve as reference to workers, architects, or machinists. So when you do a technical drawing, you're putting measurements, generally the sizes that they need to be, and all of the different aspects that somebody that was going to build that product or project would need. So when you're ready to design the details, you make a technical drawing done with more detail and more accuracy. And so a technical drawing, here's an example of a car's technical drawing. And it represents all the information necessary for the object's construction. It's made with great precision. It's done to scale and requires use of rulers, compasses, or protractors, or drafting software such as AutoCAD or even Google SketchUp, and represents the proportions of the objects represented, respects conventions in the mode of representation. And so a technical drawing can represent things as simple as a spoon, which you can see the technical drawing here shows the different sides of the spoon, the different views of the spoon, or as complex as a spaceship. And so here's a photograph of the Mercury spacecraft. Here's a technical drawing of that spacecraft from the top view, the orthographic view. And here's a technical drawing of the isometric projection, showing all the interior and exterior elements of that drawing. So you can see the cutaways, you can see how it would look from the top, and you can see how it's going to look isometrically from the sides. And then, of course, you can see very complex types of isometric drawings as well. So here is one of a fighter plane showing all the different aspects of a bomber jet. And you can see the different cutaways, you can see how it is taken apart and shown all the different areas and aspects of that drawing. So diagrams are a little bit different. So diagrams are simplified versions of drawings. Diagrams show how an object works, not necessarily how it looks. Diagrams often use abstract symbols rather than actual pictures to represent things. And so here's an example of a circuit diagram. It doesn't show what the circuit looks like, but it tells an electrician how it's all connected. Here's a diagram of an energy conversion unit. It does not show what the unit looks like, but rather what it does or how it works, going from boiler to liquid pressurizer, turbine generator, and condenser. And then you have exploded views. So a diagram that shows an object taken apart is sometimes called an exploded view. And you can see here is one for a plug or a drive shaft piece. So the difference is you have sketches. They're made without drafting tools, just a pencil and paper. Scale is approximate, not accurate, but the sketch should look like the object. The drawing is made with drafting tools, rulers, set of squares, protractors, or compass. The scale should be accurate and the drawing carefully made. And then you have diagrams. Diagrams show how an object works, not necessarily how it looks. So from this point, you're going to review the remainder of the video and take notes wherever you see that red lightning bolt symbol. Pause the video as needed. There is a practical exercise at the end. Okay, I'm back. So here's an isometric drawing example. And so what you're going to do when you look at this, you're going to see that you have a top view. It shows that hole in the center, and it shows that square where the top extends out. You have the front view where you can see that it has that hidden line, right? Don't forget the hidden lines to show where the hole is. And it also shows, again, that little top projection. And then you have your right side. So the challenge would be if you only had the front view, the top view, and the right side view, could you draw this shape? And so this is going to be one of those projects, one of those challenges that you are going to have today with the practical exercise. And so you're going to have a top view, a front view, and a right side view, and you're going to have to draw that shape. So what I want you to do right now is copy down this information. Make sure you copy down exactly how the slide shows it. And so that way you have that in your notebook when we move on and you get to the practical exercise. So different types of projections. You have that oblique projection. It's similar to the isometric projection. It also has a simulated perspective. In the oblique projections, the side of the object facing you is drawn square and accurate, and the sides not facing you are distorted. So this is the accurate side. You can see the square, and those would be the sides that are not accurate. And so you've seen this. Sometimes people are drawing in that 3D view, and this is oblique projection. Orthographic projections flatten one view of the object onto a sheet of paper while retaining the correct proportions, angles, or dimensions. Maps are often examples of orthographic projections or top views. The trouble with the orthographic projections is that one of the views usually isn't enough. And for example, maps and floor plans are exceptions where one top view is often enough. And so here's an example of a multi-view orthographic projection. And so again, this is kind of like what we did with the isometric drawings. You have the back views, you see the left side, you see the front sides. And so it's multiple views, all angles, so that way you can see how they meet up. Draws an object as it would be seen from several different directions. The views are flat with all angles shown correctly and all measurements to scale. So that way when you put this together, it's like a puzzle. It's going to show you what that shape is going to look like. And here is that shape. So this is that orthographic projection multi-view. So comparing projections, so perspective drawings look nicer when they're used by artists, but isometric, oblique, and multi-view drawings give more accurate information when used in technical drawings. Isometric drawings show accurate dimensions but distorted angles. Oblique drawings give accurate dimensions for one side only, and then orthographic multi-views are the best choice for most technical drawings. And so here's some examples of that isometric, perspective, and oblique, and then that orthographic multi-view. So here's the comparison chart for projections. And so you have the different projections on the left side, what they're used for, and then what they're tested on. And so when you look at true perspective, 1, 2, or 3 points, artistic drawings, conceptual sketches, they're not tested. That is one that is not tested. And then oblique, simulated perspective, is conceptual sketches only, and again, they're not tested. Scale is the relationship between the measurement of an object drawn on a sheet of paper and the measurement of the actual object. Make sure you write that in your notebook. Often technical drawings are made of different size from the objects they represent. Scale reduction is when the drawing is smaller than the actual object, and scale increase is when the drawing is larger than the actual object. So at this point, go ahead and, again, you're going to enjoy some music while you're reading through these slides. Okay, guys, this is your practical exercise. So you're going to complete this assignment in Schoology. You can either use the slides that I've provided, or you can draw the shape in your notebook and attach a picture of your final drawing. And so you're going to see here, you have the top view, You have your front view, and then you have your right view. Please pay attention to the hidden lines that are shown here within the drawings, as those are going to indicate the shape of this item. So this is the challenge. I want you guys to try to come up with what that is going to look like. And when you get into Schoology, you will also see the answer. Once you see the answer, if you have not gotten that answer yet, make sure you go back and complete that and then submit it as today's assignment. I hope everybody enjoyed this presentation. If you have questions, please let me know. Otherwise, have a great day.